All right, today we're going to start chapter 9, which is called polar coordinates. This is something that you have not seen before. So please make sure that if you do have questions that you ask. So first of all, a couple vocab words real quick. So when you're talking about polar coordinates, the words like x-axis, y-axis, and origin are going to change a little bit. When we talk about what we would consider the origin, that is called the pole. And then the x-axis is considered the polar axis. Okay, so those are just a couple vocab words that we will use throughout the course of the chapter. So the pole is the same as the origin, and the polar axis is the same as the x-axis. All right, so what are polar coordinates? Polar coordinates is a point that's written in the term r comma theta. R is the distance from the pole, so the origin, to the radius. So it's basically the radius of the circle. And then theta is the angle that's formed by the polar axis, or the x-axis, and a ray from the pole through a particular point. All right, to graph in polar coordinates, it's going to be a little bit different. The first thing is we rotate to the angle. Okay, so we always graph the angle first, or look at the angle first. And then if r is positive, we move out onto that ray in the positive direction. And if r is negative or less than 0, we move our directions the opposite ray. Okay, so again, those are some directions. You rotate to the angle. If r is greater than 0, we move out onto that ray. And if r is less than 0, we move into the direction of the opposite ray. All right, so let's take a look at some points. So this is an example of polar graph paper on the right. So you'll see that you've got your angles as you go around in radians and degrees. Those angles would just be like those angles of the unit circle. And then we have a bunch of circles. And again, that's what we were just talking about, where you move out that many circles onto the ray. All right, so I'm going to start first by graphing this point in purple. So again, this is my r and this is my theta. So it says go to pi over 4, which pi over 4 is right here. And since 2 is positive, it just tells us to go 2 circles, so 2 circles out onto that ray. And that is the point right there. I'm going to call that point A, where I rotate to the angle of pi over 4 and go 2 circles out. All right, I'm going to switch colors and do the next one in orange. So now it says go to 2 pi over 3, which is over in quadrant 2. And then it says go negative 3. So again, negative 3 means go in the opposite direction. So this is the ray that would be positive. The opposite ray is the one that goes in the opposite direction. So what I have to do is I have to go 3 circles, 1, 2, 3, out in the opposite direction. So that point right there is point B. Okay, so I'm going to erase that line because that's not part of it. But we go on that same diameter, I guess, if you want to think about it, just the opposite direction. So if we take a look at the next point, I'll do that one in blue. It says rotate to negative pi over 3 degrees. Well, I know pi over 3 is up here, so that means negative pi over 3 would be down at 5 pi over 3, right? I rotate in the backwards direction. All right, but then it's positive 4, so here's my ray. I'm going to go 1, 2, 3, 4 units out, and there is point C. So again, the actual ray itself isn't part of it, but point C is 4 units out, since it was a positive 4, onto that ray. All right, the last one I will go ahead and do in green. And it says rotate to pi and then go negative 2. So again, pi is all the way over here. And if it was positive, I would go in that direction. But because it's negative, I go in the opposite direction. So it would be technically on the 0 axis, and that would be the point D right there for 0 pi. It would be 2 units out on 0 pi. So again, if r is positive, we go out onto that ray that we are looking at. And if it's negative, we go in the opposite direction on that opposite ray. All right, so let's take a look at some more points. Some of them are in degrees. So I'm going to do this first one in green. So it says rotate to 150 degrees and then go negative 3. So again, 150 degrees is over here. But again, I don't go in the positive direction. I want to go 1, 2, 3 in the negative direction. And there would be point A. All right, the next one says 2 comma 315. So again, this is my r and this is my theta. I'm going to do that one in blue. It says go to 315 degrees and go out 2 units. So I go to 315 degrees, and because it's positive, I'm going to go out onto that ray, and there would be point B. All right, the next one I'm going to do in red, and it says go to 5 comma 0. So really, we don't know if it's 0 pi or 0 radians, and really it doesn't matter. 0 would be over here. And it says rotate to 0 and then go out on that ray 5 units. So 1, 2, 3, 4, 5. So that would be point C right there. And again, it doesn't matter if it's degrees or radians in this case, because 0 pi and 0 degrees is the same. All right, the next one says rotate to pi over 3, which is up here, but because it's -3, remember we want to go out on that opposite ray. So I want to go 1, 2, 3 units out on that opposite ray, and that would be point D. And again, I'm going to get rid of those rays because that's not part of the graph. All right, and then the last point I'm going to go ahead and do in black, and it says go to 4 pi over 3. 4 pi over 3 is down here, and then it says go out 3 units. And I go out 1, 2, 3, and what do you notice? You notice that point D and point E are the exact same point. So one of the things we're going to talk about today is how can I name the same point different ways? And in this case, these two guys right here, letter D and letter E, represents the exact same point. All right, so some of the problems that you're going to have on your homework have these directions. It says plot the point P in polar coordinates. And again, remember that's r and theta, 2 comma pi over 4. And then find other polar coordinates r comma theta of the same point for which, and then we have 3 different scenarios here. All right, so first off, before we do anything, let's go ahead and plot that point. I'm not going to actually make polar graph paper, but we know that we have to rotate to pi over 4, and pi over 4 would be out here. And then I guess I could make a little bit of graph paper. If I do 2 quick circles, since it's +2, I would go out right here, and there is the point 2 comma pi over 4. I would go out 2 circles, so it would be a point that falls in quadrant 1, and again, this ray would have been pi over 4. All right, so we are going to have some rules for naming that same point. So the first one says r has to be positive. Well, first of all, in order for me to get to this point, I have to go out 1, 2 units, so I know that r is going to be +2. Right? R has to be positive. I can't change r to 3 or 4. It still has to be 2. The only difference for this point is going to be the angle. So it says theta has to be between -2 pi and 0. So theta has to be a negative angle. So basically what we have to do here is instead of rotating to pi over 4 in the positive direction, I want to rotate the other way in the negative direction. So if I think about fourths, I know 4 fourths is pi. I know 8 fourths is 2 pi, 8 pi over 4, right? So those we've done before. How far do I have to rotate back? So this would be 4 fourths. We know that this is another 2 fourths up here, so that'd be 6, and then one more would be 7 fourths. So I'm going to rotate back -7 pi over 4. And that would be the coordinates of the same point. So if I go back here and I get rid of that, so if I were to rotate backwards, I would have to rotate 7 fourths negative in the 7 pi over 4 in the negative direction, and then go out 2 units to get to that same point. Okay, another way to do that is I could have just taken that pi over 4 and I could have subtracted 2 pi or 8 fourths, and that would have given me -7 pi over 4, which would get me to that angle. I just want to go a full circle backwards, and that would be just subtracting 2 pi. All right, so the next one says r has to be less than 0. So again, I know I have to go 2 circles out, but we want r to be negative, so I know r has to be -2. All right, so remember, if the r value is negative, we go on the opposite ray. So that means if I'm looking for the angle, oops, I want to switch colors. If I'm looking for the angle, we've got to actually be down here on that same diameter down in quadrant 3. So I'm going to rotate, and again, we want it to be from 0 to 2 pi. I've got to rotate to whatever this angle is right here that's on the same ray as pi over 4. Well, if you think about it, that's a half circle away. So if I take pi over 4 and I add pi, or if I add 4/4, that would give me 5 pi over 4. So if you think about that graph paper we were just doing, I'm going to go back. If I rotated to 5 pi over 4, and then I want back 2 units, that would be on the ray pi over 4. All right, so let's take a look at the last one. The last one says r has to be greater than 0. So that means r has to be 2. Okay, and again, I'm going to get rid of those circles here. Since r is 2, I want to end up on this ray and then go 2 units out. However, I want theta to be from 2 pi to 4 pi. So that means it's got to be more than one circle around. So I know a full circle is 8/4, and then I got to go one more. So that would be 9 pi over 4. I'm just taking that pi over 4 and I'm adding a full circle to pi, or in this case 8/4, and that gets me to 9 pi over 4. So if I rotate a full circle and 1/4 more and then go out 2 spaces, that would get me back to that same point. So there are a bunch of different ways that we could write the same point 2 comma pi over 4, depending on the r value and then the angle measure. All right, so let's take a look at another one. This is not going to be a unit circle value. We're going to look at 3 comma pi over 8. Okay, I do have some general rules up there, which we'll talk about in a second. So let's talk about 3 comma pi over 8. So I know that pi over 8, if this is 0, this would be, this would be 8/8. This would be 16/8, 16 pi over 8 over here. So I know that 4 pi 8 would be up there. So I know that pi over 8 is somewhere in quadrant 1. And I want to go 3 circles out. So if I draw 1, 2, 3 circles out, that would be somewhere approximately right there. All right, so again, we've got our stipulations. These are different now. R is greater than 0. So again, I like to go ahead and do R first. I know if R is bigger than 0, R has to be 3 because I have to go 3 circles out. Next one says R is negative. So I know it's going to be negative 3 comma something because R has to be negative. The last one, R is positive, so it's got to be 3 comma something. Okay, so now let's do the angle measures. So I know if it's positive, if R is positive, I have to end up on this ray and then go the 3 circles out onto the ray. If I want this to be bigger than 2 pi, so between 2 pi and 4 pi, I have to go a full circle around and another pi over 8. So I know a full circle is 16 pi over 8, plus one more would give me 17 pi over 8. So again, I'm taking that pi over 8 and I'm adding 2 pi, but in this case, 2 pi is 16/8, right? I want to keep that common denominator like we've done in the past, so I've got to add 2 pi. All right, if I look at the next one, it says R has to be negative. So that means I have to end up on the opposite ray. And then I want to go back 3 units to get to that same point. So what would that angle be? Well, I know my reference angle here is pi over 8. So that means my reference angle is going to have to be the same down there, pi over 8. So if I take that 8/8 right here and I add pi over 8, that's going to be 9 pi over 8. Okay, and again, one of the ways we talked about it is we know that that's pi units away. So I'm just taking that angle, pi over 8, and I'm adding pi, or adding 8/8. All right, the last one, I know that that angle, or the R value is positive, so that means I need to end up on this ray, on that pi over 8, but I want my angle to be negative. Okay, so that means in order to get there, I have to go a full circle back to get to that angle. So if I take pi over 8 and I subtract 2 pi, that's subtracting 16/8. So that gives me negative 15 pi over 8 as my angle. Okay, so if you take a look at the general rules, if R stays the same, right? So if we want the R value not to change, we add or subtract a multiple of 2 pi because we want to end up at on that same ray. But if the sign of R changes, we want to be on that opposite ray, so we just want to go a half circle, so we just add a multiple of pi. an odd multiple of pi. So I could either add 1 pi, I could add 3 pi, which would give me a round and another half circle. So 1.5 circles. But you're going to add an odd multiple of pi. Usually it's just pi. All right, so what would a polar point P look like as a point on the rectangular coordinate system? So what would it look on an XY axis? So you can see that I have that graph paper over there, the polar graph paper. So that rotated to pi over 3, and I went out 1, 2, 3 circles. So that would be a little bit more than the point 1, comma 2, maybe 1.1, comma 2.1, or 1.2, comma 2.2. But realistically, the pole and the origin would be the same point, right? The x-axis is what we call the pole. And then we would rotate to those points, either on the polar coordinate, rotate to the angle and go out that many circles, or, go over 1 up 2. So I know it's pretty close to the point 1, comma 2. All right, so taking a look at this, what if I told you this about the following point? So in polar coordinates, we have the point 2, comma pi over 4. That's our r and that's our theta. And that's the same as the point root 2 over 2, comma root 2 over 2 in rectangular. Rectangular coordinates are just our normal xy coordinates. Okay, so the point 2, comma pi over 4 is exactly the same as the point root 2 over 2, comma root 2 over 2. All right, how can we find that? Or how can we use this information to find x and y? So let's take a look at this picture on the left. Okay, how can we use the information about what we know about r and theta to find x and y? All right, so I know I'm going to rotate theta degrees, right? So there's my theta, and I'm going to go out this many r's for point P. I don't know how many it is, but that's how I would graph that point P with rectangular coordinates. Well, with polar coordinates. If I was doing x, y's, I would go over x, up y. So I know this is the point r, comma theta, and it's also the point x, comma y. So what we have to do is we have to find a link to or between those points r, comma theta, and x, comma y. Since we do have a right triangle here, we can use good old SOHCAHTOA to figure out the link between those. All right, so if I wanted to figure out something about, let's say something about x, okay? I know x is the x, or that's the rectangular coordinate. R is the polar coordinate. So what can I say about that theta? Okay, so this is my opposite side of theta. This is my adjacent side of theta, and then r is my hypotenuse. So I know that cosine of theta has to be adjacent over hypotenuse. So in this case, it's x over r. Okay, and that's something that we've talked about before. If I multiply both sides by r, that gives me x is equal to r times cosine theta. And that right there is my link between theta and r and the x value. All right, so let's do that exact same thing, but let's talk about y. So we know y is the opposite side. R is our hypotenuse. So if we do opposite and hypotenuse, we know that's going to be sine. So sine of theta is equal to y over r. If I multiply both sides by r, that tells us that y is equal to r times sine of theta. So if I have an r and a theta, I can just go ahead and plug in whatever r is, whatever theta is, and then find x and y. All right, so again, there are formulas. If we have a point P in polar coordinates with r theta, we can use rectangular coordinates, or we can find the rectangular coordinates by using the equations x equals r cosine theta and y equals r sine theta. So let's go ahead and take a look at a couple examples. Sometimes you'll need your calculator, sometimes they're going to be nice unit circle values. So if we take a look at the point 5 comma pi over 4, we know there's our r and there's our theta. Okay, so let's think about where 5 comma pi over 4 is. We know pi over 4 is that ray right there in quadrant 1, and we've got to go 1, 2, 3, 4, 5 circles out, so that would be somewhere in quadrant 1. So we know the x and the y values have to both be positive. Okay, so if we want to find x, we have to do r times cosine of theta. Well, that's going to be 5 times cosine of pi over 4. Well, I know cosine of pi over 4 is root 2 over 2. So if I do 5 times root 2 over 2, that gives me an x value of 5 root 2 over 2. Obviously, I could plug that into my calculator if I wanted and approximate it. All right, if I want to find the y value, I have to use the equation r times sine of theta. So again, my r is 5, and this time I'm doing sine of pi over 4. Well, sine of pi over 4 and cosine of pi over 4 are the same, so that's going to be 5 times root 2 over 2. So my y value is also 5 root 2 over 2. So the rectangular coordinate in xy that's the same as 5 comma pi over 4 is going to be 5 root 2 over 2 comma 5 root 2 over 2. Okay, so if I were to go over whatever 5 root 2 is, comma 2, or over 2, and then go up, I would get to that same point. All right, we're going to use our calculators for the next one because we're going to talk about the point -3 comma 75. So again, we want to plot that point first. If I rotate to 75, that's somewhere here in quadrant 1. But remember, since that r is negative, we want to go down into quadrant 3, and we want to go out 3 circles, so it would be somewhere approximately there. So we know the x value has to be negative, and so does the y. So again, if we find the x value by doing r times cosine of theta, that's -3 times cosine of 75. I'm just going to go ahead and throw that into my calculator. Make sure you're in degree mode, and that's approximately equal to 0.78 negative, so negative 0.78. If I want to do the same thing and find the y value, I have to do r sine of theta. Sine of theta. So that's going to be -3 sine of 75 degrees. Sine of 75 degrees times -3 gives me approximately for y, -2.90. So the ordered pair that would be equivalent to -3 comma 75 degrees, which is a polar coordinate, if we want to find the rectangular coordinates, it would be -0.78 comma -2.90. So again, if they're unit circle values, make sure you keep them unit circle values or nice square roots like example A. And if it's something that's not on the unit circle that we know the XY coordinates for, the sine and the cosine value for, go ahead and use your calculator. And that's all for today.